Hello and welcome back. In our last couple of videos, we've talked about parent functions and transformations. To do a quick recap of the different effects of the various transformations on our parent functions, we have a, h, and k. A is anything we multiply by the front of our equation, and that is going to either vertically stretch, shrink, or if it's negative, it could reflect the graph. Stretching if we multiply by a value that's greater than 1. Shrink happens when our value is between 0 and 1. And a reflection happens anytime your a value is negative. H, notice here, is minus h, so that opposite of whatever our value is inside with the x is going to be a horizontal shift. And k added onto the end is a vertical shift. So in number 1, I'm going to look at the transformations and I'm going to apply them in order. There are 3 numbers that I see, so each of those numbers is going to apply a different transformation. When we write our transformations, we always work from the inside out. We follow the order of operations. So the first thing I'm going to do is deal with the 2 that's inside. That 2 is a minus 2 inside with the x. So that minus 2 is going to be a horizontal shift opposite what we would think. So minus 2 means we are going to shift to the right 2 units. After we do inside the grouping symbols, we then go on to anything that's multiplying. We work from the inside out. Multiplying by 3. Multiplying allows our values to get bigger, which means we are going to stretch. So this is a vertical stretch by 3. It's not negative, so we don't have to worry about any reflections. The very last thing we do, just like last in the order of operations, is any addition and subtraction. So the addition and subtraction on the end is going to be a vertical shift. And vertical always stays the same as what we would think, so plus 6 does mean up 6. Number 2, the first thing that I'm going to deal with is that plus 4 that's inside. So that is a horizontal shift, but plus does mean we're going to the left 4. Working our way out, after we do inside the parentheses, we then go on to multiplication and division. So the second thing that I'm going to do is multiply everything by 1/2. It is outside, separate from the x. It's not included in the parentheses with the x. It's separate. So this is a vertical stretch. Since we're multiplying by 1/2, it's not going to be a stretch. It is going to be a vertical shrink by 1/2. Multiplying by 1/2 causes your values to get smaller, so that would be shrinking the graph. And then last, number 3, we're adding and subtracting, so this is a shift. It is separate from the x, so it is vertical, which leaves us with a vertical shift down 7. So what we're going to do with the rest of our notes today is actually create these graphs. Number 1, I have a graph 4 times the absolute value of x plus 3. Well, I know how to graph the absolute value of x pretty easily. If I create a table for myself, it's not so bad. I like to do 0 and then a couple numbers below 0 and a couple numbers above 0. To find the y values, I just plug those in. The absolute value of negative 2 is 2. The absolute value of negative 1 would give me 1. The absolute value of 0 is 0. When I plug in a 1, y equals positive 1. And when I plug in a 2, y equals positive 2. So this is what my table looks like, which means my parent function looks something more or less like this. I suggest you draw it very lightly, if at all, because we're only going to use this as a guide and we don't want our graphs to get too confusing. Now we spoke about applying transformations and working from the inside out. So working from the inside out, I'm going to take this plus 3 and apply the transformation of shifting everything to the left 3 units. So every dot goes left 1, 2, 3. The dot here goes left 1, 2, 3. This dot goes left 1, 2, 3. We could do more, but those are all we have on the left side. So now I'll move these couple on the right, move it to the left 1, 2, 3, and then move it to the left 1, 2, 3. And there's my new graph. So I shifted my graph to the left 3 units. One thing that we can do instead of doing it graphically is take our table and just subtract 3 units from every x value. You'll notice when you do this that you end up with the 5 ordered pairs that we have. So this would become -5, -4, -3, -2, and -1. So -5, 2, -1, 2, 3, 4, 5, 1, 2 is this point right here. -4, 1 is this point. -3, 0 is here. -2, 1 is here. And -1, 2 is here. So we didn't have to graph the red thing. We could have just adjusted our table and found the ordered pairs from the table. Either way you choose to do it's fine. One of the reasons you might not want to graph is because we're not done. Now we need to go ahead and deal with this 4, which means we are going to multiply or stretch everything vertically by 4. Your x values do not change, but your y values get multiplied by 4. So if I focus on this point here, it has a y value of 2. When I multiply by 4, my y value is now 8. The x value does not change, only the y values. The second dot has a y value of 1. When I multiply by 4, my new y value is 4. So 1, 2, 3, 4. My y value is now here. This point has the coordinates -3, 0. The y value is 0. When I multiply by 4, I still get 0. This y value is 1. When I multiply by 4, I get 4. This y value is 2. When I multiply by 4, I get 8. The x's did not change. We just pulled things upwards. And our graph now looks like this. One thing that we could have done instead of doing it right on the graph is just taken our table and multiplied all of the y values by 4. I think doing this makes your graph a lot less stressful. So this y value would be 8, 4, 0, 4, 8. And our new ordered pairs would be -5, 8, -4, 4, -3, 0, -2, 4, and -1, 8. I'm going to use only the table to graph number 2. I've got my x's and my y's. I'll use the same values I did before. -2 squared is 4. -1, if I put -1 in, -1 squared is +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. I'm not going to graph it yet because I want to apply all my transformations first. Working from the inside out, the first thing I'm going to do is shift everything to the right 1. Or I'm adding 1 to all of the x's. So I take my entire x column and I add 1. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Those are my new x values. The second transformation I do is the negative. I work from the inside out. That is a vertical reflection, or it is multiplying by negative 1. So I'm going to multiply negative 1 to all of the y's. We know that it's the y's because it's not directly attached to the x. It's separated. It's on the outside of those parentheses. So I multiply by negative 1 to all of the y's. I get negative 4, negative 1, 0, negative 1, negative 4. And those are my new y values. The last thing I have to do is my plus 5. This is a vertical shift, up 5. What that means is that we are adding 5 to all of the y's. So I take all of my new y's and I add 5. I end up with 1, 4, 5, 4, 1. And then from these values, I create my ordered pairs. X is negative 1, y is 1. The x value is 0, y is 4. X is 1, y is 5. X is 2, y is 4. X is 3, y is 1. And I plot these 5 ordered pairs. My first point is negative 1, 1. Then I have 0, 4, 1, 5, 2, 4, and 3, 1. What I have here is a parabola that has been reflected. It's facing down. It's been moved left 1 and up 5. All right, I'll do one more for you and then I'll have you practice number 2. Looks like I swapped our parent functions. Number 1 is x squared, and number 2 is absolute value of x. So I build a table for my x squared function. Negative 2, negative 1, 0, 1, 2. When I plug those values in, negative 2 squared is 4, 1, 0, 1, 4. The first transformation, I work inside and I do the opposite. This is inside on the x, so I'm subtracting 5 from my x's. Minus 5, minus 5, minus 5, minus 5, minus 5. When I do that, I've got negative 7, negative 6, negative 5, negative 4, negative 3. And I no longer need this row. The second thing that I do is I'm going to multiply the outside by negative 3. This is going to stretch and reflect at the same time. So I'm going to multiply negative 3 to all of the y's. We know it's y's because it's outside. It's not stuck with the x. So I multiply by negative 3 to all of my y values. When I do that, I get negative 12, negative 3, 0, negative 3, negative 12. The last thing that I do is I shift my graph vertically up 8, which means since it's on the outside, I'm adding 8 to all of the y's. So adding 8 for y's means adding 8. Multiplying by negative 3 means multiplying by negative 3. Because they're on the y's, they're outside. But anything inside, we switched. That was why we subtracted 5 from our x's. So we keep the y's as adding 8. I add 8 add 8, add 8, add 8, add 8. And my new table is negative 4, positive 5, 8, 5, and negative 4, giving me the ordered pairs negative 7, negative 4, negative 6, 5, negative 5, 8, negative 4, 5, and negative 3, negative 4. Plotting these, my origin is right here. I'll mark it so I can see it a little bit better. Negative 7, negative 4, I go left 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4. That's my first stop. Negative 6, 5, so negative 6, up 1, 2, 3, 4, 5. Negative 5 and 8, so negative 5, 1, 2, 3, 4, 5, 6, 7, 8. Negative 4, 5, and negative 3, negative 4. So my graph was reflected. It was stretched. It was shifted left 5 and up 8. All right, I'm going to start you off with your table for number 2, and then I'll let you guys do this one on your own. Our table will use negative 2, negative 1, 0, 1, 2. The absolute value of all those numbers would be 2, 1, 0, 1, 2. You are going to add 2 to the x's, and then you are going to multiply negative 1 to all of your y's. Go ahead and pause the video and practice graphing number 2. I'm adding 2 to all of my x's. So I've got 0, 1, 2, 3, and 4. And then for my y's, I go ahead and I multiply by negative 1. And I get negative 2, negative 1, 0, negative 1, negative 2. And my ordered pairs are 0, negative 2, 1, negative 1, 2, 0, 3, negative 1, and 4, negative 2. So those dots then, 0, negative 2 would be here, 1, negative 1, 2, 0, 3, negative 1, and 4, 2. This is an absolute value function, so we should be expecting a V shape. And sure enough, that's what we have. So your graph has been reflected and shifted to the right 2 units. All right, this is where we're going to stop for today. Thanks so much for watching, and have a great rest of your day.